In 1991, a set of skeletal remains was officially excavated from a shallow grave in a birch forest near the city of Yekaterinburg in the Russian Urals. The remains had been lying there since July 1918, over 7 decades. Scientists then did something that would have seemed like science fiction to the people who placed those bones in the ground. They extracted DNA from the skeletal material and began a forensic identification process that would eventually resolve one of the most persistent mysteries of the 20th century. Who exactly was buried in that grave, and was anyone missing? To understand why those questions had haunted the world for 70 years, you have to go back to the night of July 17, 1918, to a house in Yekaterinburg known as the Ipatiev House, and to the last hours of the Russian Imperial family. Tsar Nicholas II had ruled Russia since 1894. By the standards of the early 20th century, he was not a uniquely brutal ruler, but he was a profoundly inadequate one. A man whose deeply conservative instincts, religious fatalism, and complete inability to read the political currents of his era made him the wrong person in the wrong position at a hinge point in history. The disasters of the Russo-Japanese War, the 1905 revolution, and above all, the catastrophic management of Russia's involvement in World War I, eroded whatever legitimacy the Tsarist system retained. When the Bolsheviks seized power in October 1917, the fate of the imperial family was effectively sealed. The Romanovs were held under house arrest first at the Alexander Palace, then transported to Tobolsk in Siberia, and finally moved to Yekaterinburg, a city in the Urals under firm Bolshevik control, in April 1918. The Ipatiev house, commandeered from a local merchant, became their final prison. Nicholas, his wife Alexandra, their 4 daughters, Olga, Tatiana, Maria, and Anastasia, and their only son Alexei, who was 13 years old, lived there under close guard for 78 days. On the night of July 17, 1918, the family, their physician Dr. Yevgeny Botkin, and 3 household staff members were woken before midnight and told to dress. They were led to the semi-basement of the house. A guard unit entered the room. And then the shooting started. The details of what followed were reconstructed from witness testimonies gathered by White Army investigators in 1919, and later by Soviet-era documents declassified after 1991. The family did not die easily or quickly. The jewels that had been sewn into the clothing of the daughters and Alexandra, concealed as emergency currency, deflected bullets and prolonged the ordeal. The guards ultimately used bayonets and pistol shots at close range to ensure all 11 people in that room were dead. In February 1920, a young woman was pulled from a canal in Berlin, having apparently attempted to take her own life. She was taken to a hospital, and when she regained consciousness, she refused to identify herself. She was eventually placed in a psychiatric institution. Over the following months, it emerged, gradually, then all at once, that this woman claimed to be the Grand Duchess Anastasia Nikolaevna, youngest daughter of Tsar Nicholas II, survivor of the events in the Ipatiev house basement. The woman's name, as would eventually be established, was Anna Anderson. Her account of her survival was elaborate. She claimed to have been rescued from the bodies by a compassionate Bolshevik guard, sheltered by a family of sympathizers, smuggled across the border into Romania, and eventually brought to Berlin. The details shifted over the years, as details in stories like this tend to do. What made Anna Anderson impossible to dismiss, at least for a significant portion of the public and even some members of the Romanov extended family, was the combination of specific things she seemed to know and her physical resemblance to photographs of Anastasia. She knew details about life inside the imperial palaces that, she and her supporters argued, only the real Anastasia could have known. She recognized people. She spoke Russian with a Polish accent, which she explained by her ordeal. She had scars and physical characteristics that her supporters argued matched documented descriptions of Anastasia. European high society in the 1920s and 1930s was fascinated. The case became one of the most covered media stories of the interwar period. Some Romanov relatives accepted her. Others, including key members of the family who had known Anastasia personally, flatly rejected her. Anna Anderson pursued legal recognition of her identity in German courts for decades. The case dragged on from the 1930s until 1970, generating thousands of pages of testimony and expert analysis. The German courts ultimately found that she had failed to prove she was Anastasia, but also declined to definitively declare her an imposter. She died in the United States in 1984. Her husband had preserved tissue samples from a medical procedure she had undergone. Those tissue samples would eventually be subjected to DNA analysis, and when the results came back, they resolved the question she had kept alive for over 60 years in a single, definitive moment. The cultural impact of the Anna Anderson story cannot be measured purely in legal and scientific terms. Her claim generated books, films, theatrical productions, and a 1956 Hollywood film starring Ingrid Bergman that won 2 Academy Awards. The story became embedded in popular culture in a way that the scientific refutation has only partially dislodged. The grave near Yekaterinburg was not discovered by archaeologists following a methodical research program. It was found in 1979 by 2 Russian men working in a context that required them to keep what they had found absolutely secret. The 2 men were Alexander Avdonin, a geologist, and Yeli Ryabov, a filmmaker with connections to the Soviet Interior Ministry. Both were Romanov enthusiasts who had spent years researching the family's fate, combining official documents with local oral history and physical surveys of the forest terrain around Yekaterinburg. When they found the grave, they were living under a Soviet system that did not officially acknowledge that anything had happened to the Romanov family beyond the execution of the Tsar. The broader family massacre was not part of the official Soviet historical narrative. Avdonin and Ryabov understood immediately that what they had found could not be publicly disclosed. They removed 3 skulls for examination and then reburied everything, keeping their secret for over a decade. It was not until the Soviet Union began to collapse, and with it the ideological constraints that had made the secret necessary, that the grave was officially opened. In July 1991, exactly 73 years after the massacre, an official Russian government team excavated the site and recovered 9 sets of skeletal remains. The physical state of the remains was consistent with what the 1919 White Army investigation had suggested. The bones showed evidence of sulfuric acid damage, consistent with documented attempts to destroy the bodies using acid. Several skulls showed gunshot damage. The bodies had been buried in 2 layers, with wooden planks between them, suggesting some care in placement, despite the evident attempt at concealment. Crucially, the count of 9 sets of remains did not match the count of 11 people who had been in that basement in 1918. Nicholas, Alexandra, and 3 of the 5 children were eventually identified. But 2 individuals, the young Tsarevich Alexei and one of the daughters, not yet determined, were absent from the grave. Where were the other 2? The 9 sets of remains, found in 1991, were examined by a multidisciplinary team that included forensic anthropologists, forensic odontologists, and DNA specialists from Russia, the United Kingdom, and the United States. The physical analysis of the bones, measuring skeletal dimensions, examining dental records where available, and assessing age and sex indicators, allowed a preliminary identification of which remains belonged to which individuals before the DNA analysis was even complete. The adult male skeleton with gunshot damage to the skull was consistent with a man in his late 40s. identifying 9 sets of damaged, acid-affected skeletal remains, from remains that were over 70 years old, from a case where no direct DNA comparison samples existed, required a forensic strategy of remarkable ingenuity. The core technique was mitochondrial DNA analysis. Mitochondrial DNA, the genetic material found in the mitochondria of cells rather than in the cell nucleus, is inherited exclusively through the maternal line. A person's mitochondrial DNA is identical to their mother's, their grandmother's, their maternal great-grandmother's, and
so on back through generations of female ancestors. This makes it useful for identifying individuals by finding living relatives who share a maternal line connection. The question was, who among the living shared maternal line ancestry with the Romanov family? The answer came from one of the most remarkable genealogical connections in 20th century European royalty. Prince Philip, Duke of Edinburgh, husband of Queen Elizabeth II of the United Kingdom, was the grand-nephew of Tsarina Alexandra through the maternal line. Alexandra's mother was Princess Alice of the United Kingdom. Princess Alice's daughter, Victoria of Hesse, was Prince Philip's maternal grandmother. This meant that Prince Philip and Tsarina Alexandra shared the same mitochondrial DNA lineage, the same unbroken female line inheritance passing from a common maternal ancestor. Prince Philip agreed to provide a blood sample. The comparison between his mitochondrial DNA and the mitochondrial DNA extracted from the skeletal remains was conducted by Dr. Peter Gill at the British Forensic Science Service Laboratory in 1992 and 1993. The match was positive. The skeletal remains included individuals who shared the maternal line mitochondrial DNA sequence of Tsarina Alexandra, connected through Prince Philip. The identification of Alexandra and at least some of her children was scientifically confirmed. The mitochondrial DNA sequence recovered from the Yekaterinburg remains and matched to Prince Philip was subsequently also compared against samples from James Carnegie, the third Duke of Fife, another living male-line descendant of Princess Alice through a different genealogical branch. The match between the Carnegie sample and the Yekaterinburg remains provided an independent confirmation of the identification, reducing the possibility that the match with Prince Philip's sample was a coincidence of random genetic similarity rather than a genuine family connection. Multiple independent reference comparisons reaching the same result is the gold standard of forensic identification, and the Romanov case met that standard. But the identification of the male remains, those of the Tsar himself, presented an additional complication that would require. Identifying the skeletal remains of Tsar Nicholas II should have been straightforward in principle. The Romanov dynasty had extensive genealogical records. Finding a living male-line relative who could provide a mitochondrial DNA comparison through the maternal line was achievable. The identified male-line maternal relative was the Tsar's brother, Grand Duke George Alexandrovich, who had died in 1899. His remains were interred in the Peter and Paul Cathedral in St. Petersburg. Russian authorities agreed to exhume the remains for sampling. The mitochondrial DNA extracted from George Alexandrovich's bones was compared to the mitochondrial DNA from the adult male skeleton in the Yekaterinburg grave. The comparison showed a match, but with a complication. Both the skeletal sample and the Grand Duke's remains showed a condition called heteroplasmy, the presence of two slightly different versions of a particular mitochondrial DNA sequence within the same individual. This was, in 1994, an unusual finding, and some scientists initially used it to question whether the identification was certain. The controversy was resolved definitively by an additional comparison. Investigators accessed a preserved blood sample from a shirt
worn by Nicholas II in 1891, when he survived an assassination attempt in Japan, a saber attack by a Japanese police officer in the city of Otsu. The shirt, with its bloodstains, had been preserved in a Japanese museum. The mitochondrial DNA extracted from the blood on the shirt matched the skeletal remains and showed the same heteroplasmy pattern. The identification of Tsar Nicholas II was confirmed beyond reasonable scientific doubt. The grave also contained the remains of the family's physician, Dr. Botkin, and the 3 household staff members. Their identification was confirmed through dental records and comparisons with photographs and family records. Every person who had been in the Ipatiev house basement on the night of July 17, 1918, except for 2 of the children, had been identified in that Yekaterinburg grave. The Russian state recognized the identifications. In July 1998, Nicholas II, Alexandra, and 3 of their daughters were reinterred with full state honors at the Peter and Paul Cathedral in St. Petersburg, the traditional burial place of Russian Tsars. The official Russian identification process was not without controversy. The Russian Orthodox Church initially declined to accept the scientific findings and refused to participate in the 1998 burial, maintaining that the identifications had not been proven to a sufficient standard of certainty. The comparison methodology, extracting mitochondrial DNA from remains and matching against living relatives, became the template for subsequent royal and historical identity cases around the world. While the official Russian identification process was establishing who was in the Yekaterinburg grave, a parallel scientific investigation was addressing the other great Romanov mystery. Was Anna Anderson who she claimed to be? The key to the Anna Anderson case was a tissue sample. In 1979, before her death in Charlottesville, Virginia in 1984, Anderson had undergone an intestinal operation at a hospital in Charlottesville. The hospital had, as standard medical practice, preserved a tissue sample from the procedure in the pathology archive. After Anna Anderson's death, her husband, John Manahan, had also preserved further biological material. These samples, intestinal tissue sections in paraffin wax, represented the only available source of Anna Anderson's DNA. The DNA analysis was conducted in 1994 by Dr. Peter Gill at the same British laboratory that had worked on the Yekaterinburg remains, and independently by scientists at Pennsylvania State University. The methodology was the same as in the Yekaterinburg work: mitochondrial DNA extraction and sequence analysis. The comparison was made against 2 reference sources. First, the mitochondrial DNA of the Yekaterinburg remains identified as the Romanov family, to test whether Anderson was related to them. Second, the mitochondrial DNA of living relatives of a Polish factory worker named Franziska Szankowska, who had disappeared in Berlin around 1920. A woman who had previously been proposed as the real identity behind Anna Anderson. The results were unambiguous on both counts. Anna Anderson's mitochondrial DNA did not match the Romanov family remains. She was not related to Tsarina Alexandra through the maternal line. She was not Anastasia. And her mitochondrial DNA was a perfect match for the living relatives of Franziska Szankowska. Anna Anderson was a Polish factory worker who had lost her family, suffered what appears to have been a serious psychological breakdown, and constructed, or been drawn into constructing, an alternative identity that she then maintained with remarkable consistency and apparent conviction for over 60 years. Whether she truly believed her own story, or whether it began as a deliberate fabrication and evolved into something she could no longer escape, is a question the DNA cannot answer. What the DNA did answer, completely and permanently, was the factual question she had kept open for 6 decades. Franziska Szankowska, the real woman behind the Anna Anderson identity, had a documented history of mental illness prior to her disappearance in 1920 and had survived a factory explosion that left her physically and psychologically damaged. The circumstantial details of her life, the timing of her disappearance, her physical description, her documented instability, were consistent with a person who might construct or accept an alternative identity in the aftermath of severe trauma. One of the most historically significant findings from the complete Romanov DNA analysis, completed when the remains of all 11 individuals from the Ipatiev house were eventually identified, was the confirmation of the genetic basis of Tsarevich Alexei's illness. Alexei Nikolaevich, born in 1904, was the only son of Nicholas and Alexandra and the heir to the Russian throne. He was also severely ill from early childhood, with a condition that his parents and the imperial court managed with desperate secrecy for years. The condition was hemophilia, the inherited inability to form adequate blood clots, which meant that any injury, even a minor bruise or cut, could trigger dangerous and potentially life-threatening bleeding episodes. The disease came from his maternal ancestry. Queen Victoria of the United Kingdom, who died in 1901, carried a mutation in the gene responsible for producing factor IX, one of the clotting proteins required for normal blood coagulation. Victoria appears to have acquired this mutation as a spontaneous genetic event rather than inheriting it, since there is no evidence of hemophilia in her parents' families. She passed the mutation to several of her daughters, who carried it silently and transmitted it to their own children. Alexei's mother, Alexandra, was one of those carriers. She passed the mutated gene to Alexei. The 2009 DNA study that analyzed the skeletal remains from the second Yekaterinburg grave, where the remains of Alexei and one of his sisters were eventually found, was able to sequence the relevant portion of the X chromosome from Alexei's remains. The analysis confirmed that Alexei carried a mutation in the F9 gene, consistent with hemophilia B, also called Christmas disease, a rarer form of hemophilia than the more common hemophilia A. The specific mutation had not previously been documented in the historical and medical literature about the royal disease, making the finding a genuine scientific contribution to understanding how the disease moved through the European royal families of the late 19th and early 20th centuries. The connection between Alexei's illness and the political collapse of the Romanov dynasty runs through a Siberian mystic named Grigory Rasputin. Alexandra's desperate need to manage Alexei's condition and Rasputin's apparent ability to calm the boy during bleeding episodes, possibly through suggestion and reduction of anxiety, gave Rasputin an influence over Alexandra that extended into political appointments and court decisions. The 2009 study that confirmed the hemophilia B diagnosis was conducted by a team including Evgeny Rogayev of the University of Massachusetts and the Russian Academy of Sciences. The 1991 discovery and the subsequent DNA identification had accounted for 9 of the 11 people known to have been in the Ipatiev house basement. The Tsar, the Tsarina, 3 of the 5 daughters, and 4 retainers had been found and identified. But Tsarevich Alexei and one of his sisters, either Maria or Anastasia, the question remaining which one, were not in the grave. The absence of 2 individuals sustained a residual hope in some quarters that perhaps, somehow, they had survived. This was the thread of possibility that had always supported the Anna Anderson legend, and it remained alive as long as the remains of 2 people were unaccounted for. The resolution came in 2007. A group of archaeologists and researchers, following up on historical accounts and continuing physical surveys of the forest near Yekaterinburg, found a second burial site approximately 70 meters from the first. The new site contained burnt and fragmented bone fragments, the remains of 2 individuals who had been subjected to more thorough destruction than those in the first grave. The bones had been burned and then buried,
in an apparent attempt to eliminate them as evidence entirely. The damage to the remains was severe enough that conventional archaeological analysis could not definitively identify them. Advanced DNA extraction techniques, developed in the years since the first analysis, were applied to the fragments. Techniques capable of recovering usable genetic material from burned and chemically degraded bone that would have been entirely unusable by 1992 standards. The 2008 DNA analysis, conducted by a team that included scientists from the US Armed Forces DNA Identification Laboratory, extracted and sequenced mitochondrial DNA from the fragments and compared them against the reference profiles established from the first grave, from Prince Philip's sample, and from other royal family reference DNA. The results confirmed that the fragments were the remains of two individuals, a male and a female, both bearing the Romanov mitochondrial DNA signature. The male was identified as Alexei Nikolaevich, Tsarevich of Russia, aged 13 at the time of his death. The female remains were identified as belonging to one of the daughters, with the DNA evidence most consistent with Maria Nikolaevna. Anastasia was among the three daughters whose remains had been found in the first grave. The search was over. All 11 people from the Apatiev house basement had been found and identified. None had survived. The second grave's discovery and the subsequent DNA identification effectively ended the last scientific basis for any survival theory. The hope that had sustained the Anna Anderson legend and numerous other imposter claims over the decades, the genuine uncertainty created by two missing people, was eliminated. The scientific identification of the Romanov remains answered the question of who was buried and where. But the physical evidence from the bones themselves, combined with what is known from historical records, photographs, diaries, and the testimony of those who knew the family, allows a reconstruction of how they actually lived in the years before their captivity and in the months of imprisonment that preceded their deaths. The Romanov family was, by the standards of the early 20th century, unusually close-knit for an imperial dynasty. Nicholas and Alexandra had a genuine love marriage, unusual among royal families of the era, where dynastic considerations typically overrode personal preference. Their children were raised with a relatively informal domestic life inside the formal ceremonial apparatus of the Russian court. The daughters shared rooms, did needlework, kept diaries, corresponded extensively, and were, by the accounts of everyone who knew them personally, unremarkable young women who happened to live in extraordinary circumstances. Bone chemistry analysis of the Romanov remains confirmed a diet consistent with aristocratic nutrition, high-quality protein, diverse food sources, and no evidence of the nutritional deficiencies that marked the remains of ordinary Russians from the same period. The family had lived well, and the physical evidence of their remains reflected that. The genealogical relationships between the Romanovs and virtually every other European royal family of the era meant that the question of who bears responsibility for allowing them to remain in Bolshevik custody, when rescue was at least conceivable, was and remains charged. King George V of the United Kingdom was Nicholas II's first cousin. They were so physically similar that photographs of the two men standing together show an almost uncanny resemblance. George V initially supported the idea of offering the Romanov family asylum in Britain, then withdrew the offer under pressure from his government, which feared the reaction of the British left to sheltering a deposed autocrat. The DNA evidence has a footnote to add to this story. The close genealogical relationship between the British and Russian royal families, both descending from Queen Victoria and from the Danish royal house, means that the mitochondrial DNA of Queen Elizabeth II
and the mitochondrial DNA of Tsarina Alexandra were essentially identical. Prince Philip's contribution to the identification of the Romanov remains was not just a forensic technicality. It was the British royal family providing the biological key that confirmed the identity of the Russian cousins their grandfather had declined to save. Let's bring the entire Romanov DNA story together, because it is not simply a historical whodunit resolved by clever forensic science. It is a case study in what DNA identification can and cannot do, and what it means to close a chapter of history that has remained open for nearly a century. The technical achievements of the Romanov identification were significant milestones in the development of forensic ancient DNA science. The case was among the first major public applications of mitochondrial DNA analysis for historical identification purposes. The handling of the heteroplasmy complication in the Tsar's DNA established methodological precedents for how to deal with the biological variation that exists within single individuals. The 2008 analysis of the burned and fragmented remains from the second grave pushed the boundaries of what could be extracted from severely damaged material. Each stage of the investigation contributed techniques and approaches that subsequently became standard in the field. The Anna Anderson case was equally significant as a proof of concept for using historical tissue samples in identity determination. The use of paraffin-embedded hospital pathology material as a source of ancient DNA, a methodology developed in part through the Anderson investigation, has since been applied to hundreds of other historical identification and genealogical research cases. What the DNA closed, definitively and permanently, was the possibility of survival. For decades, the myth of Anastasia, and to a lesser extent the myth of Alexei, had persisted because there was genuine uncertainty. Two people were unaccounted for. Where genuine uncertainty exists, human imagination fills the gap, and human longing for stories in which the innocent survive shapes how that imagination works. The Anastasia myth was not a cynical fabrication sustained purely by fraud. It was, for many people who believed it, a genuine expression of the human unwillingness to accept that 11 people, including 4 teenage girls and a sick 13-year-old boy, were taken to a basement and killed. The DNA removed the uncertainty. It did not remove the tragedy. What happened in the Apachev house on July 17, 1918, was confirmed by the science. All of them died. Nicholas, Alexandra, Olga, Tatiana, Maria, Anastasia, Alexei, and 4 people who chose to stay with the family when they could have left. Dr. Botkin, the cook, Ivan Karitonov, the footman, Alexei Trup, and the maid, Anna Demidova. The Romanov case remains the most cited historical application of forensic DNA identification, and the methodology it pioneered has since been applied to the identification of historical figures from Richard III of England to the remains of Christopher Columbus.